Today I want to identify these three sets in Venn diagram, the derivation of union of three sets. Now first, it is N of universal set U. In this universal set, there are three subsets. First set is A. So you should let it is N of A, the number of elements in set A. And another is set B, it is N of B. And third set is C, it is N of C. There are three sets, these three are intersecting. Now I want to identify all these regions. We have region 1, 2, 3, 4, 5, 6, 7, and outside this 8 there are 8 regions. The name of all these different regions are different. So you must know the name of all these regions, then you can solve your question by using Venn diagram. It will be very easy if you follow this method. So first of all, you should clear the name of all these different regions. Now you know the name of first circle is N of A, N of B second, N of C third, and the combination of all these three sets, these three sets A, B, C is the union of A, B and C. So this and this, these three circles, the combination of these three circles, that is union of these three circles, A union B union C, it is N of A union B union C. Then the combination of these three circles, this. But outside these three circles, this region is complement of this one. So outside this region, now this region is N of A union B union C complement. And don't forget, N of U total rectangle is equal to combination of these three circles and outside this part. So this plus this, N of A union B union C plus N of A union B union C complement is equal to N of U. To find out complement, subtract this result from this one. To find out this one, subtract this, then you will get, subtract this from this, then you will get this region. So the sum of these two is N of U. After this, the intersection between A and B is this region. So the name of this intersection I want to indicate here, it is N of A intersection B. Intersection between A and B. First look here, 1 2 sets this intersection portion, N of A intersection B. Similarly, A and C, this region, now it is N of A intersection C. And last, this intersection region, now this is, you can see, this is N of B intersection C. Yes, we have A intersection B, this region, A intersection C, this region, and B intersection C, this region. And this region is the intersection of all these three sets. The intersection of all these three sets is this region. So the name of this is N of A intersection B intersection C. So intersection between all these three sets is this one. Now, first look here, the intersection of A and B is this portion, and if you subtract this one, then you should tell this region is only intersection between A and B. So this is intersection, but this is only intersection between A and B. The name of this region, this region is N naught of A intersection B. This region is N naught of A intersection B. Now this one, it is, this whole is the intersection between B and C, but if you subtract this region, it is N naught of B intersection C. And this region, N naught of intersection of A intersection this, A intersection C. It should be clear. This region is intersection of A and B. But if you subtract this portion, you will get N naught of A intersection B. Similarly, this is N naught of B intersection C. And this is N naught of A intersection C. Now again, look this first circle. This is only intersection of A and B. This is only intersection of A and C. This is intersection of all these three. But this is only A. It is N naught of A. Similarly, this is N naught of B. And at last, this is N naught of C. Now look here. This one region, 2, 3, 4, 5, 6, 7. There are 7 regions inside these 3 circles, and inside N of U there are 8 regions. 7 this one, and outside 1. There are 8 regions in N of U, and there are 7 regions in N of A union B union C. Now look here. To find out from this one, N naught of A intersection B is from N of A intersection B. If you subtract N of A intersection B intersection C. Similarly, you can find out N naught of B intersection C and N naught of A intersection C. N naught of B intersection C is equal to from N of N B intersection C minus N of A intersection B intersection C. N naught of C intersection A is equal to N of C intersection A minus N of A intersection B intersection C. Try to be clear. Again, N naught of A intersection B. This portion is from total. It is N of A intersection B. If you subtract this portion, so this result. Similarly, for N naught of B intersection C, from total N of B intersection C, if you subtract this one, you will get a naught. Similarly, third also same. And to find out this portion, N naught of A, if you subtract this portion from all, you will get N naught of A. This is from N of A minus N naught of A intersection B minus N naught of A intersection C minus N of A intersection B intersection C. You will get this portion. It is N naught of A. Similarly, N naught of B is equal to from N of B minus this portion, N naught of A intersection B minus N of this portion, N naught of B intersection C minus N of A intersection B intersection C. And turn off this one. N naught of C is equal to from N of C minus this portion, and this portion. N naught of A intersection C minus N naught of B intersection C minus N of A intersection B intersection C. Yeah. Now we need to find out this one. So N of A union B union C. It is N of A union B union C is the combination of this portion 1, 2, 3, 4, 5, 6 and 7. If you all add all these regions, you will get this one. So N naught of A first, N naught of B second, N naught of C third, plus this is N naught of A intersection B plus this one N naught of B intersection C plus N naught of A intersection C, and this one plus N of A intersection B intersection C. 1, 2, 3, 4, 5, 6, 7. If you add all these 7 regions, you will get N of A union B union C. But N naught of A is this one, this result. N naught of B is this result. N naught of C is this result. and not of B intersection this one, A intersects and not of A intersection B this region, and not of B intersection C this region, and not of A intersection C this region. And if you substitute all these values at last, you will get, after substituting all these values, you can see n of A union B union C is equal to n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of C intersection A, and at last plus n of A intersection B intersection C. If we write down this formula directly, it will be complicated to understand how can this plus. So if you substitute all these value in this notation, you will get this result. Try to solve this one, you will get this one. But don't confusion, you can use either this formula or this formula, and all these are your formula for these three sets. So this one is formula number 1, this is formula number 2, this is formula number 3, this is 4, this is 5, this is 6, this is 7, and this is 8, and at last n of u is equal to n of A union B union C plus n of A union B union C complement. It is formula number 9. If you take the concept of this Venn diagram, you can use this information, given information in Venn diagram, then you can solve directly. But it is not necessary to understand these process. But don't forget, how can this region from all this intersection portion, if you subtract this one, we will get this one. And how can this region from all n of A, if you subtract this, you will get this one. If you can find out like that way, it will be easy for you. So it is not necessary to learn all these formula. It is your concept. So try to solve first. How can you plot your information in your Venn diagram? Try to do this one, then after you can solve. But it is very lengthy method, so you can take this formula or this one, or your easier way is you can solve your question by using Venn diagram. It will be the best for you. Then don't forget, the name of these are different. I'll give you this concept in another class. Thank you.